Hello guys, welcome to another maker interview from 3D Jake. Last time we had Wyatt Weaver from Atom Engineering, and before that Adam from Vector 3D. If you want to check out those videos, links in the description. This time, however, I am very happy to welcome Joshua Rowley, co-founder of E3D. So Joshua, thank you so much for joining us. It's wonderful that you're able to join us here on YouTube. So first of all, it's hard to introduce you. I've thought of this so many times. Because E3D is just such a well-known company, I just couldn't think of an introduction. So instead, I want to ask you, how did all of this get started?
That was very, very flattering for you to say. Yeah, for sure. The E3D name has been around in the industry for over 10 years now, actually. And I think it's fair to say certainly a lot of the old guard, the kind of the main 3D printing community, I think they've heard the name. E3D started out basically, as I said, about 10 years ago, when my two business partners, Sanjay and Dave, were looking to figure out a way to bring 3D printing into education. So E3D actually stands for Education in Three Dimensions. Sanjay and Dave were both teachers at the time. They bought a 3D printer. It was a little Huxley. Their intention was to use that printer to print parts for other printers and sell those. And also as part of this process, develop a scheme of work and a teaching program that could be used in UK schools to teach kids about 3D printing. That's where the name came from. And in the development of these printers that they were printing, which were based off Mendel 90s, Sanjay developed his, he made a different type of hot end. So rather than going out and buying a JHead, which he had to buy from America and they were shipped in, he decided, well, look, I'm just going to make this out of a lump of aluminium, which was in fact a student's project, one of Dave's students' projects, hacked to pieces to form the first E3D hot end. I don't think the guys really thought much of it at the time. They mounted this on a printer. It worked really well. They posted a few pictures online about this printer offering them up for sale. And people were responding saying, oh my God, that's, I'm not actually interested in buying the printer, but I'm really impressed with what you've managed to do with the hot end there. And it was at that point that Sanjay and Dave realized they were onto something quite special and quite novel, and that they'd found a way to basically make a hot end in a way that hadn't been done before without using PEEK. And that is really the genesis of the all-metal hot end. Now, the story's been told so many times, and the truth is, I wasn't there. I was a good friend of Sanjay for years before. But this was very much Sanjay and Dave, back at the beginning, developing this stuff. So they made the first few versions of the all metal hot end, which was being sold on our website back then. And I joined to develop what was V6, which is lasted really a very long time. It's kind of still out there in the market. People are still using it, and E3D really set the standard for all of this stuff. And there have been countless products and innovations that we've come out with that surround, that core concept of the all-metal hot end. Lots of different designs of nozzle, lots of different kind of technologies around nozzle. Obviously, we've branched out into extruders as well. We had a quick foray into slicers back there for a year or so. And also we have, of course, have launched 2 printers in our time, or technology development platforms, I think we probably prefer to refer to them as. So yeah, sorry, it's slightly confused history of E3D, but that's kind of where it all started. And I think it's fair to say that 10 years ago, when the RepRap movement was really taking off, E3D built a name producing high quality components for that space. We were really popular with all of the hobbyists who were building their own 3D printers, and we shipped hundreds of thousands of hot ends over the years.
Can you tell us about Sanjay's initial prototype? I want to get into the dirty secrets here. So come on, tell us. This was the first all-metal hot end.
The very, very first all-metal hot end was on a Mendel 90, which has 2 horizontal linear rails. And it was designed. It was a lump of aluminium that had the 3 bearing holes milled out of it, and I think it was even cable tied onto the carriage. And then underslung was with fins for a fan that sat underneath, and then a hot end that dropped down with a heat brake, with a stainless steel heat brake. And look, Sanjay had just gone back to first principles and was like, okay, well, this bit needs to stay cold because otherwise it's going to melt my bearings, and this bit needs to stay hot, and I'm going to use something that doesn't conduct too much heat so I don't have to get the heat away. He was really lucky, we were all really lucky that Sanjay was working at a school in Norfolk where he happened to have a CNC lathe available to him, so he was able to knock up these prototypes really quickly and easily. And that's kind of where it all started. And I think it's the other amusing thing, of course, is that the M6 nozzle thread that we're now all so used to came from a welding tip, because I think that the first nozzle that he used was from a welding tip, which had an M6 thread on it. And that is where the M6 standard that we all know and love today comes from.
So how old are you guys then? You've been what, early 20s?
I am well, back then, yes, a lot younger than now. So I'm 33 today, which would have meant that I was 23 back then. Sanjay would have been 23, 24, that kind of age.
So, okay, a welding tip as the nozzle, that's where the M6 thread came from.
That's where the M6 thread comes from.
And now it's just so ubiquitous, and it came from a welding tip. That's insane.
And also, I mean, I'm sure you've heard all the stories about, 2.85 filament originally coming from the basically strimmer lines.
That's the nylon line. So
exactly, that's where that whole alternative standard evolved from. There's a lot of, of course, that is 2.85 or 3 mil or whatever you want to call it is now, of course, declining quite significantly in popularity. But it's funny where all of these little sort of standards came from in our industry.
Weird question. People, especially in the UK, actually tend to refer to 2.85 as 3 mil. Is there any reason for that, or is it just because they don't want to say the extra decimal points?
I think there was actually, it was not always 2.85. I think there was a time when it was 3 mil. So the original V6 hot ends are actually 3.2 mil diameter inside, because there was filament that was in fact 3 millimeters. It was 2.85, and I think there was 2.9 and 3 mil. There were several variants that were available at one time. Anyway, thank God the world has moved on.
I'm pretty happy with the 1.75 right now, actually.
Which again, actually, that's Stratasys. I mean, gosh, I'm probably going to be fact-checked on a whole load of this stuff and re-educated. But as far as I remember, that is a Stratasys standard. I believe that they came up with that. Some guys back in the the Stratasys glory days when they held all the patents, those guys had assessed that 1.75 was the correct number, and I don't know I don't know how much work has been done since then to reassess whether that's the right dimension, but it's something that we've explored with changing, because it's not optimal in all circumstances, of course.
So you and Dave and Sanjay, were you guys all in university together, or did you meet elsewhere?
Actually, Sanjay and I went to Newcastle University together. We were both well into rifle shooting. Actually, that was our hobby, and we ended up living together and making all sorts of crazy, stupid stuff in our student housing. We ended up running a small distillery, of course, and our landlord discovered it, and rather than kicking us out, he said he just silently doubled the insurance policy on the house. Didn't kick us out. I'm forever grateful to Dave. Sanjay is a year older than me. He left university, went down to Exeter, where he studied teaching, which is where he met Dave. Dave was a teacher. I had another year of university while they did their teaching qualifications, and then we all started work at the same time. As Sanjay and Dave's passion grew for 3D printing, I kind of got caught up with it, and I didn't stop making stuff when I left university. Got a job. I was just doing it in my free time, and 3D printing was a really exciting thing for me back then. And so I spent a lot of time with Sanjay. I designed my own 3D printer based on the, oh my goodness, I actually don't remember the name now. The big Kossel, the Rostock, actually.
Oh, the Delta one, yeah.
I built this enormous Rostock from scratch. I re-CAD'd everything. It's great fun. And that's the first time I used one of our hot ends was on that.
How fast was the Delta back then?
It was really slow. It was really slow. They were all 3D printed, components. Back when we were using those IGUS bearing.
Oh, the bearings, yeah.
Yeah. I actually don't remember the speeds, but slow.
That was at the point when everyone was using ABS instead of PLAs.
Actually, no. This was PLA days. This was PLA days.
PLA days.
Yeah,
Okay.
yeah. Because we obviously had Fabadashery in the UK that was so. At the university down, not far from us here, actually, they decided. Again, what's the guy's name? Andrew Dent decided that it would be a good idea to use a bit of PLA because it had the right properties. It was a low shrink rate. It had a relatively low melting temperature. It was more environmentally friendly than other materials. So PLA suddenly gained a lot of popularity off the back of work done in UK universities.
So what kind of relationship did you have with the RepRap movement back then? I mean, how widespread was it in the UK, and how did it develop?
I think it was really widespread actually. There were a lot of there was a lot of 3D printing interest in the UK, both in makerspaces and universities. But makerspaces, schools, universities. But I would say it's one of the most peculiar things about the kind of the growth of E3D. I remember when we were telling our friends and family, like, we've got this company selling parts for 3D printers. They would ask, "Oh, so when are you guys going global?" And I was like, "What does that even mean, going global?" Because from the very beginning, it was an online enterprise. The RepRap forums were totally global. We were running a website that, except that we took shipping and we sent things into Royal Mail International all over the world from day one. And there was no concept of going global because I think that the RepRap movement was just so international. And that was one of the most, exciting and exhilarating things about it, because you could send designs and STLs and collaborate on a physical thing on a printer with someone that was over in New Zealand. And in fact, that is what we were doing for a period of time. So I think, to me, that was part of the allure of it. It wasn't just a UK-based industry. It was very much online and very international, literally from day one.
Then what year was your first product released, actually?
Gosh, that's a good question. I would say 2013. That was the V. I think we went straight in with V4. This is before I was officially part of E3D. There was the V4, then the V4.1. I supported a little bit with the design of V5, and then by the time I was properly with Sanjay and Dave, we worked on V6 and quite quickly released that, which, as I said, has been a kind of that was the major product that was selling for the longest period of time for E3D.
And then it all started.
Exactly.
So actually, I want to talk about more recent news. So what was it, a couple of weeks ago, I think you guys have announced that you are basically retiring the tool changer.
Yes.
And it has been like a pretty pivotal design in the last few years, and it seems nowadays that everyone is coming up with some sort of tool changing platform. Why exactly was it retired?
So for us, it was never a 3D printer. We didn't design it and manufacture it and sell it as a 3D printer. It was always designed as what we call the technology demonstration platform internally, whatever that means. But the concept really was less about producing a printer that we could sell. It was more about pushing the whole concept of tool changing and pushing the envelope with what could be done with a printer that was able to do more than just print. So we wanted to, in the kind of the spirit of the RepRap heritage that we came from, we wanted to create this thing, open source all the bits of it that would enable people to develop alternative tools, whether that's inspection, whether that's pick and place, whether it's, additive, subtractive, whatever that might be. So we wanted to facilitate that. And so we produced this printer and we put it out on the market in the hope that it would kind of excite and inspire people and push the whole technology forward. And I think that it's achieved exactly that objective. It's now out there in the market. There's a lot of printers that now do tool changing. I think the most notable is the Pria XL, which looks quite visually similar to the tool changer. And I think for us that is a real sign of success, and we're so happy to see that the community has taken it forward, and that it is now we are now starting to see tool changing. I would say that the vision was never quite realized, in as much as we haven't now got lots of really fancy tool chains, like the software tool chain. Yeah, of course, the Duet guys and many others are doing some interesting stuff with inspection, but I don't think that's really part of the 3D printing workflow yet. Of course, Bamboo are doing some interesting stuff in a totally different way. We were happy with how it went, and we really, it was an amazing product, and frankly, it does make a great printer and a brilliant research platform. But as a commercial proposition, it's expensive. It's made of it's not designed for mass production, and with the market for printers becoming even more accessible, its price just didn't put it in a good place in the market. So we felt that it had run its course, it had achieved its objective, and so it was time for it to be retired.
What did you call it exactly?
We call it a technology demonstration platform.
Technology demonstration platform. Is that intentionally vague?
Yeah, I mean, no, not really. I think it was more of a kind of internal joke. It was like, because we'd say, it looks like a printer, it sounds like a printer, and it moves a little bit like a printer, but it is absolutely not a 3D printer, is what we would say internally. Because we didn't want, we had previously a few years previously launched a thing called Big Box, which was another open source 3D printer, which again was relatively successful, but it was not well placed for scaling up and mass production. And I think we'd learnt our lesson with that it wasn't the direction that we wanted to take the company, and B, that it was a complex thing, and so there was a little bit of reticence internally about do we really want to do this printer? And everyone was like, well, no, it's not a printer, it's a technology demonstration platform. And so there was there was just a bit of a joke about that internally, which is why it got that name.
Do you guys have any more plans for any more technology demonstrations?
There will be more technology demonstration platforms, but they won't look like printers this time. They will be in different form factors.
Because E3D is so well known, and that the V6 especially, you find it everywhere.
Yeah.
You do see a lot of products that are basically copies of the V6 and other kind of products that E3D has come out with. How do you feel about all of these copies and variants?
Of course, super delicate question. So certainly for the V6, that product was designed to be open source, and all those years ago, that was very much in the spirit of how things worked and how the community worked, and so we designed it to be open source. So frankly, so long as people are not using our brand and claiming something to be an E3D product, it's not the kind of thing that we can or will say anything about, because that was the framework under which those products were launched. Of course, things have changed a lot since then. That was, as we were just talking about, 10 years ago. I can't believe it was all that time ago, but things have changed a great deal now, and I think that the market is much more reliant on companies that will properly invest in developing new technologies, because there is less low-hanging fruit. It takes a lot of time to develop things that will truly move the dial and improve the 3D printing technology landscape as we see it now. And that doesn't come for free. It costs a lot of development work, and I think it's fair to say that it is outside of the realms of being a hobby. We obviously tread a fine line, but I think we have had to be harder in recent years, and that's no secret.
I remember back in the day when actually sort of be around 2019 or something. I think when we first partnered together, there were, you would find so many V6 knockoffs all over the internet. It looks exactly the same, except when you notice the heat break. The heat break looked perfectly similar, and then you look in and there's a PTFE insert in it. I don't know why they would always call it a JHead as well for some reason.
Who knows how the who knows how it works, like how those decisions are made, and how the product titles on AliExpress are chosen. I suspect it's around like hitting as many search terms as possible. I don't know who in 2019 is searching for a JHead, but evidently someone is, because otherwise you'd have thought that you wouldn't bother putting the title in, or maybe it's just been copy and pasted for the last 5 years hence. I honestly can't say.
Regarding patents and IP, so you guys initially, I think your first IP was it on the volcano? Didn't you have like a design patent on that or something?
We had we had design patents on certain elements of V6 as well. Actually,
Okay.
we were a bit late to the party, and we were able to get some designs registered, which, because you can in some jurisdictions do that after having published, which of course you cannot with patents, which gave us a little bit of kind of protection against people that were trying to just claim to be exactly us. But I think that the first, I believe it's been the Revo patent, proper patent.
Are you guys open to further releases in future, which will be completely open source? Because the climate has changed, like you said.
I think, yeah, for sure. I don't. There are some products and some concepts and some ideas that, yeah, I think that the open source community would really benefit from them, and the product, whatever it might be, would benefit from that ecosystem. And where that is true, for sure, there's absolutely nothing. There's no reason for us not to. But I think that, what it comes down to is brass tacks. We will do so if it makes sense, because the market is just so much more competitive now than it ever has been. So we will do so if it commercially makes sense. And I hate that it's come to that, but it's the truth of the matter, right?
What exactly is the relationship between the high flow Revo and the Bontech CHT, and how are they related in their source to 3D Solix design?
The E3D high flow design uses some features which we felt the need to license from Bontech, and Bontech themselves licensed that patent from 3D Solix. Certain aspects of the design, you could argue, play onto the CHT patent. So we wanted to act in good faith, work with Bontech, and the guys have been great. And I think we've got a good relationship, really good relationship going there, which I'm looking forward to building in the future. And I think it's a great model of how things can work going forwards, because I truly believe that relationship and that arrangement that we have come to together represents a win for everyone, because previously Revo customers couldn't get a high flow option that could have trodden on Bontech's toes, and so that precluded any CHT customers from having quick change, certainly in the Revo way, and it prevented Revo customers from having high flow, certainly in the CHT way. And so bringing those two things together clearly made sense.
Speaking about relationships with other manufacturers, E3D and Pria have had a long relationship. How did that start exactly? Because just Pria was involved in RepRap from an early stage with the variations on the Mendel. So how did that relationship actually begin? How did that spark?
I think that we first started working together, it must be 6 or 7 years ago now, when they were buying V6s for the MK3. 2016, I think it was, that it started. Yeah.
So was that started with the Mark III, or did it start with the Mark II?
It was actually Mark II. Sorry, it was actually the Mark.
Oh, yeah, okay.
It was the i3 Mark II.
You guys were working on the XL together, but it wasn't going to be a Revo style hot end, right?
The guys then, we were working together on the new machine, or the new nozzle for their new machines. And that is what you see on the XL and on the MK4. So, we've spent the better part of 3 years, collaborating with Pria, working backwards and forwards on kind of prototypes and iterations. And it's taken a lot of work from E3D's side, producing prototypes and whatnot for for the guys at Prusa to bring that nozzle to where it is now.
Yeah, going back to the Revo, actually, I have two. I got one on the Prusa there. There's the Revo 6, and I got a micro somewhere around here. I'm not sure where. But yeah, how has the reception been to the Revo in general? Because it's a big ecosystem. Like compared to the V6, the V6 was huge as well, and now the Revo is just expanding. And recently we have the high temp Revo now.
I think it's fair to say that the majority of people love it and they're really happy with it. The Revo ecosystem has, I think, it's just dramatically improved the usability of a lot of printers. Certainly for people that have applications where they need to change nozzles, where they're printing small stuff at high detail, they're printing fast stuff, they're printing with abrasives, high temperature. The ability to just swap out the nozzles or the heater core does make a huge difference, and we get some really positive feedback on it. And I think we're very, very satisfied with how the launch has gone, how the product is going. I would love to have rolled out more of the ecosystem more quickly, and the fact that I think it was coming up to 2 years ago that 18 months or so since we first launched Revo, to just be bringing out high temp now, we would love to have brought that out sooner, but now we're getting to we're fully rounding out the ecosystem. That's really satisfying.
Tell us about the Sanjay Mortimer Foundation, because it's been a couple of years now almost. How has that developed since its inception?
So the Sanjay one, very, very briefly, of course, Sanjay passed away back in November, coming up to 2 years ago now. And for those that were not aware, Sanjay suffered from ADHD, and he was very open about that. And what I saw in him actually was his energy, his enthusiasm, his passion. He would channel into making and 3D printing and just generally his hobbyist activities, and being online, being part of the 3D printing community, being part of something bigger, and like having energetic people to bounce ideas off. And that was just a huge part of his relief, actually, and what enabled him to channel his energy into something that was really constructive and positive, and so on and so forth. And I think that where Sanjay was incredibly lucky was that he found that outlet, because he wasn't great at university. I'm sure he wouldn't mind me saying. And academia never really suited Sanjay. For anyone that knew him, they would understand exactly what I mean. Academia didn't suit him, but that didn't stop him from being a really intelligent, hugely intelligent individual that had the kind of mental capacity to change the world, certainly changed the world of 3D printing. And I think that speaks volumes to the impact that these kinds of conditions have, and the opportunity that the world has to work with people that have those kind of conditions. I don't know, and to help them find a better way forward. And so the Sanjay Mortimer Foundation is really focused on that. It's about finding people for whom mainstream education isn't quite working in the way that it should do, and helping them find kind of relief, an outlet in making, be that 3D printing or not. Of course, it has a strong slant towards 3D printing. But yeah, that's the vision. We're very happy with how things are going at the Sanjay Mortimer Foundation, and we really believe in what we're trying to achieve here, because it was such a big thing for Sanjay, and I think something that a lot of people in the community will really resonate. It will really resonate with them. We actually have a RepRap festival in the UK called the Smurf, the Sanjay Mortimer RepRap Festival, which is on the 2nd and 3rd of December here in Oxford, which is a kind of fundraising event for the Sanjay Mortimer Foundation, and indeed just a RepRap festival for the sake of having a RepRap festival, because they're awesome. So if anyone happens to be or fancy being in Europe in early December, then you should definitely come along. It's being held in the examination rooms at Oxford University, so it's like proper Harry Potter vibes. It'll be really cool. It should be a fun event, and also for a good cause, of course.
So I asked this question to pretty much everyone I interview, and it's always different, the answer, I mean. What do you think is going to happen to 3D printing as a field in the next couple of years?
The impossible question. I guess the key question is by what metrics. I think that the number of consumer printers in the consumer market is probably about where it's in a good place, and I think it has a little bit of growth left in it. But honestly, I don't think that there's huge growth left in that side of the market. And companies that are producing ever more integrated solutions, you know the names. I don't need to mention them. I think they're doing really well, and they're making 3D printing more accessible. And so I hope that does create a little bit more of an expansion. But I think it's fair to say that now industry is starting to catch up. I see a lot more scope and a lot more opportunity in the industrial side of things, where people are really starting to pick up on additive manufacturing. What I am sad to see is, I think, a bit of a decline in the makerspace, to be honest. There are far fewer people that build 3D printers for the fun of it and for the enjoyment of it. And that have the patience to rip apart a 3D printer. I think there are several factors driving that. Firstly, there are fewer gains to be made, as I was saying 20 minutes ago. There is just less. There's less low-hanging fruit, and I think that gives less opportunity for someone to say, "Oh, I've got a cool idea for how to make this better. Let me just print this, adjust that, remodel that, work with a couple of guys online, and make a thing that's better." There's just a little bit less scope for that now. Maybe that's defeatist, and hopefully I will be proven wrong. But I get that vibe.
Thank you so much for joining us, Joshua. It's been wonderful to talk to you, and we wish you all the luck in the future for E3D and the Sanjay Mortimer Foundation.
Awesome. Thank you so much, Buffy. Have a great day, and thanks everyone for listening.
Thank you. Thank you so much.